Okay, lab answers for our last chapter of t-tests. Here are repeated measure t-test labs. So problems you were assigned were problem number 3, parts A and B. So 3 says a researcher conducts an experiment comparing 2 treatment conditions with 15 scores in each condition. A says if an independent measures design is used, how many subjects are needed for the experiment? So if it's independent measures, remember that means separate samples. So if we have 15 scores in each sample, we would need 15 people in the first sample and 15 new people in the second sample. So 15 people plus 15 people means we need 30 total people. For 3B, if a repeated measures design is used, how many do you need? Well, we're going to recycle those folks, right? So we got 15 in the first sample and the same 15 people in the second condition. It's the same sample, it's not a second sample. So it's still just 15 people. So A is we need 30 people, B is we need 15 people. Next up was question 18, parts A, B, and C. And so 18 says a sample of different scores from a repeated measures experiment has a mean of different scores of 3 points with a standard deviation of 4. Part A says if the sample size is 4, is this sample sufficient to reject the null hypothesis using a two-tailed test 0.05? Well, we don't have to do all 4 steps here, but we're going to have to do a lot of them anyway. So remember, the first thing here is that it told us for this problem, number 18, that the mean of different scores was 3 points, and that the standard deviation, and it's really, remember, the standard deviation of difference score, so I'm going to put that down there just for our consistency, equaled 4 points. Well, remember, we really want variance, so we want to turn this into variance. So we know that our variance of different scores is 16 points is what we're going to end up working with here. So that's the first thing we need because we have to know our t-statistics. So first thing we've got to figure out is this part, that our variance of different scores is 16 points. From here, we can calculate our estimated standard error. So for our estimated standard error, we're going to take our variance of different scores and divide it by the number of scores as we do, and then square root, basically, again, the same formula, very similar to chapter 9, recall. So here, we've got a 16 divided by 4. Oops, sample size was, yes, it was 4, okay. So 16 divided by 4, and then square root, we have an estimated standard error of 2 points. And then lastly, the t-statistic, well, it's the mean of the different scores divided by our error. We're told the mean of different scores is 3. We're told that our error is 2. So our t-statistic is 1.50. So it asks if it's sufficient to reject. Well, we need to have our critical t value looked up. So we know it's 2 tails. We know the alpha level is 0.05. We know the degrees of freedom is 3. So our critical t equals positive or negative, where is it? 3.182. Our t-statistic is at 1.5, so we are nowhere near close. So what would our decision to be? We would need to fail to reject the null hypothesis. Then for part B, it says, would you still reject it if we increase the sample size to, or would we reject or not if we increase the sample size up from 4 scores to 16 scores? Well, the mean differences is still 3. Our variance of different scores is still 16. So the part that's going to change over here for us is in computing the estimated standard error. So we still have a 16 for the numerator, but our sample size is now 16. Sample size goes up. What should happen to error? Should go down. So 16 divided by 16 is 1, square root. And sure enough, our error goes down to 1. We had 2 points of error. We increased the sample size. It went down to 1 point of error. Sample size goes up, error goes down, error goes down. Your t statistic goes up. So now 3.00. But our degrees of freedom have changed over here. So our critical values will have changed. Our degrees of freedom are now 15. So at 15 degrees of freedom, our critical T is plus or minus 2.131. So now, we look at our T statistic of 3, and now we are in that shaded area. So now our decision would be to reject the null hypothesis. Once again, it's yet another problem in a long series of problems I give you that really is demonstrating those mantras. As I've said so many times, they really are the core of what this science of inferential statistics is about. And then one last problem is to do a full-on 4-step hypothesis test. We're looking at problem number 20, part B. So in 20 part B, there was some prep work that you needed to get done first. So 20, we won't read the whole problem for us, but I won't read the whole problem for us. You've read it yourself, but we've got all of our data here, but it gave us nothing to go by. So we are going to have to get our own different scores, our own squared different scores, our own mean of different scores, our own sums of squares of different scores. So I'm going to write some of that down on here right now. I'm not going to copy the whole chart out, but we would want to have our participants, our first set of raw scores, our second set of raw scores, in order to get our different scores and our squared different scores. So I'm just going to write those up here real quick. So our different scores are -2, -1, -4, +1, -2, -5, -1, 0, and -4. So when we square all those things, -2 squared gets us a 4, a 1, a 16, a 1, a 4, a 25, a 1, a 0, and a 16. So we need to sum each of these columns. So we know that the sum of different scores was -18. And we know that the sum of squared different scores was 68. So from there, we can do the other two prep things we need to do. We need to get the mean of the different scores. Well, the sum of different scores is -18. And the number of different scores is 9. There are 9 values there. So our mean difference score is -2. And then we also need our sums of squares to put in the formula. So our sums of squares. Here we need to know that first the sum of squared different scores was 68. And then the sum of different scores squared over the, again, number of different scores, 9. So when we calculate that out, we find we have a sums of squares of 32 points. So that was all prep work that had to be done before we could even get to our 4 steps. So now let's take a look at those 4 steps. So, step 1. The alternate hypothesis is the treated population mean of different scores. Don't forget, that's one of the places that absolutely is required. You don't have to put it on all the other symbols like I do and the authors don't, but we absolutely have to have it there. So the alternate hypothesis is the treated population mean of different scores will not equal 0. And the null hypothesis is the treated population mean of different scores will equal 0. For step 2, we are running this, it tells us, as a two-tailed test. The alpha level that's been given to us is 0.05. And our degrees of freedom is 8. There were 9 scores, 9 minus 1, 8. So our critical T is plus or minus 2.306. So that's our step 2. Step 3, doing our math. So the first thing we need to do is get our variance for the different scores. That's your sums of squares for your different scores, divided by your degrees of freedom, as always, for variance. So our sums of squares was 32 points. Our degrees of freedom is 8. So when we calculate that out, we get 4 points. Next thing is we need our estimated standard error. So here we're going to get our variance in the numerator, our sample size in the denominator, and square root it. So 4 divided by 9, then square root that answer, and we get 0.67. And then the third one is the actual t statistic itself. So the mean of our different scores was -2. And the error we have is 0.67. So -2 divided by 0.67 is basically, remember, it's going to be -2.98507, but that's only if you are using a rounded value here. Remember, we're writing down a rounded value, but we don't want to calculate with the rounded values. We actually want to divide this by 0.6666666 out to, 6, 7, 8 places is fine if you're not using the memory function on your calculator. If you calculate with the full thing, you're actually going to get a -3. So we take a look at that, compare it to our roadmap over here. That puts us in the tail. So for step 4, our decision is to reject the null. And again, for practice, if we were writing this in APA style, we would say we have a t of 8, which equals -3. And the p less than 0.05 because we reject it. All right, there are the answers for our final t-test labs.